Hello everyone, my name is Charles Shear. I'm a practicing neurooptometrist and the vision science consultant to Burtech Corporation. Today I would like to cover two key points in this presentation. First, the difference between pursuit and saccadic eye movements. And secondly, how the BVT can be used to integrate vision, motor, and balance. Tracking eye movements are also sometimes referred to as pursuit eye movements. They're basically slow, continuous movements that are used to follow an object, and their maximum speed is about 90 degrees per second, or about 18 miles an hour. Both types of eye movements are often affected with TBIs and concussions because these complicated neural pathways course throughout a quite extensive part of the brain. And that's why there's such a large opportunity for a brain injury to affect eye movements. They occur at about 70% of all concussions and TBIs. Jump or saccadic eye movements are very fast and accurate. They move up to 900 degrees per second, or about 10 times as fast as the pursuit eye movements, making them move at about 180 mile an hour. Think of that as being the difference between a golf cart and an Indy car. Just like with the pursuit eye movements, the saccadic eye movements pass through a large area of the brain, basically everywhere but the frontal lobe. Today we're going to talk about the speed mode of the BVT, and we're primarily going to be dealing with saccadic eye movement. With speed mode, like any of the modes, we usually want to establish a baseline for this patient because that's what we're going to be comparing going forward. We're going to compare him to himself. So for baselines, we want to use a black background, a green target. We'll use a large grid size, a large target scale, which controls the size of the target. We're going to use large sensitivity. We're going to use a 15-second duration instead of 30 as we normally would for the sake of the video. Should be self-pacing. And we're going to use touch mode as opposed to balance or combined. And the object is for the patient to see the green dot, touch it. As soon as he does, it moves to a new location. He has to make a saccadic eye movement over to that location and then move his hand there again. And we want to see how many times he can do that in, generally speaking, 30 seconds. We can make it easier or more difficult by changing the parameters. A smaller target size makes it more difficult. A smaller sensitivity makes it more difficult. Extra large sensitivity rewards them for being close. And of course, we can change the backgrounds and the targets themselves to make it appropriate for different sports. Let's choose a hockey player. We're going to use a hockey background and a hockey puck. And because we've chose sort of a small target and a black one that can get lost up in the rafters, this is quite challenging, and they have to really be searching and making really good saccadic eye movements in order to perform the test. And of course, we can choose a wide variety of different backgrounds and targets, anything from other sports to grocery store background for living skills. For our patients and athletes who have vestibular problems, we want to make sure they get really good at the standard things before we start adding this OKN background. But this is one of our go-to therapies. But OKN stripes are very powerful, and we want to make sure that the patient is stable and not a fall risk. If they are, we need to have a harness available. Once you've selected which OKN stripes you want, you can select the little controller button. That will allow you to select and control the directionality, contrast, and speed of the stripes. Again, there to touch the green dots. The interesting part is that the stripes are stimulating a pursuit movement to the left and a saccadic movement to the right to pick up the next set of stripes. And the time this is going on, they have to control the central vision to move a saccade to those green targets. So this becomes very, very challenging. We can help them by reducing the contrast and slowing down the speed. Once we've done that, we want to just, of course, make it more difficult. My favorite set of targets are the optic flow targets or backgrounds. These backgrounds like more realistic, more real life types of things. Here you see it going from peripheral to central. We can reverse that and have it go from central to peripheral, which is more like walking down a hallway or in a tunnel. While we're doing this, there's a stimulation to the periphery of both eyes to kind of pick up those stripes, excuse me, and to track them out, but then we have to make another saccade at the target. So this becomes quite a challenge, and it really prepares the patient or athlete to return to life and to return to play. And on that note, we bring up the most challenging of all targets for some patients, and that's the grocery store. So we can do these same tasks using the grocery store. And finally, I want to say a few words about the automatic mode. This is particularly good for our patients who have had a field loss to one side or neglect. The target are going to move whether they touch them or not. So if it gets into that area where they're not seeing, they're not at a loss to sit there for a long time trying to find it. It's going to move whether they touch it or not. So this stimulates vision to that side of neglect, and it is very good at trying to get them to pay attention to that side. Please join us in the near future for a separate video on using the speed mode with the force plate. It uses the center of pressure measurements to move the cursor over the top of the target, hover on it, and that counts as a touch. Thank you very much for joining us, and we hope you enjoyed this. Look for another presentation in the near future. Thank you.